Hello, I'm going to go ahead and do a couple examples of solving quadratics by factoring. One's going to be a straightforward one, but I'm going to go ahead and do both by grouping, even though this first one there is a shortcut. So what we're going to do is we're going to have to, this one is straightforward because we have a leading coefficient of 1 that makes it a little easier. So I showed you in class how we can get these factors pretty quick, but let me refresh you. So all I'm doing is doing what times what is equal to 35. When added together, it gives you 12. So we've got to think of all the factors of 35. One of the ones that pops up immediately is 7 and 5. 35 and 1 doesn't work out too well. So we just have 7 and 5. Now again, I'm going to show you the complete factor by grouping. So I'm going to split the middle here. And it doesn't matter which term I put first. I can do x squared plus 7x plus 5x and so on. Doesn't really matter. X squared plus 7x plus 5x plus 35. And many of you have already been using the shortcut. So when we group the first two right here, and we group the second two with the sign right here. Now the GCF factoring of this is simply an x, so we have x times x plus 7. I hope I get an x plus 7 over here. And it looks like a 5 factors out, but we factor out with that positive 5 right there. And we have x plus 7. So my factors are x plus 7 and x plus 5 using that distributive property. And because of the zero product property, one of these has to equal to 0. We're going to go ahead and set them both equal to. And again, I'm going to go ahead and go through and set it up the process. We have to set them both up to equal to 0. When I subtract 7 on both sides, I get x is equal to negative 7. That's one of them. Now remember, quadratics often have more than one solution. Well, one or two solutions, or sometimes none. Then we're going to have x plus 5 is equal to 0. So when we subtract our 5 on both sides, we get x is equal to negative 5. So my solutions are x is equal to negative 7 and x is equal to negative 5. This is where the quadratic crosses the x-axis. So if I have my xy right here graph, I can have a quadratic that will go at negative 5, negative 7. I know it opens upwards because this is positive, and I'm way up there at 35 in the y-intercept, so I probably have a graph that looks like something like this, and it just goes up, intersects at 35 way up here. All right, so something like that. All right, next example. So this one, I have a leading coefficient of 2, so we're going to use that process that we've practiced again, using a little bit of mental math, but I take the first term times the last. It's still the same thing that we're doing with coefficient of 1. We just never bothered because it was a 1. So we're looking at what times what is equal to negative 10 when added together gives you a negative 3. We've got to think of all the factors, 10 and 1, 5 and 2, so on. And it looks like 5 and 2 are the winner because they're 3 apart. Biggest number gets the sign, so it's going to be a negative 5 and a positive 2. And what we're going to do is we're going to split the middle. Doesn't matter which one goes first. I'll put the 5 first since I wrote that first. So I'm going to do 2x squared minus 5x plus 2x minus 5 is equal to 0. I GCF factor here, and I GCF factor here. I probably should have done the negative because then I could have showed you how to factor out a negative. So GCF right here is nothing more than x, and I have 2x minus 5. I hope I get a 2x minus 5 over here. Sure enough, I'm going to factor out. I have to factor out with that sign. And a 1. You got to factor out something. And I have a 2x minus 5 is equal to 0. So using my reverse distributive property, I have 2x minus 5. X plus 1 is equal to 0. I set each one equal to 0 because of the zero product property. 2x minus 5 is equal to 0. Add 5 to both sides. And I have 2x is equal to 5. Inverse operation, inverse of multiplication is division, so I divide by 2 on both sides, and I have x is equal to 5 halves. That's one of my solutions. This one has two solutions. So I go ahead and set that equal to 0, and I subtract 1, of course. X is equal to negative 1. So my solutions are x is equal to negative 1, and x is equal to 5 halves. Just real quick, I just want to go ahead and show you that order doesn't matter. I could have split the middle as 2x squared plus 2x minus 5x minus 5. And when I GCF factored, that would have been a 2x this time, and I would have had x plus 1. And then I would factor out that with the negative sign, I got to factor out a negative 5, and that, of course, would have been an x plus 1. And I ended up right in the same spot. This would have turned into that right there. Alrighty, so I'm going to go ahead and get this uploaded, and I will do a quadratic formula example.